Gleasman. He said he'd prefer to be referred as Cory, but I'll still ask him in the when we start. We'll just wait for a couple more attendees and for Dr. Gleasman himself. Does anyone have any questions so far, though, that you might want to ask Dr. Gleasman? He is a professor at Tennessee Tech. Oh, you are in the webinar. Oh, great. Let me just add you as the presenter. Make a presenter. Okay, you should have just added you as presenter. Should come up as a pop-up, Cory. Let me know when that comes in, and you should be able to share your video as well, or your what's the word? Face camera as well. There we go.
Can you hear me okay?
Yes, I can hear you perfectly.
Okay, perfect. I know I was here. I felt like I was in Inception. I was being talked about, but I couldn't see or speak, and I was trying to speak to you. So thank you. Thank you for having me.
No, thank you for willing to participate. We've just reached 4 p.m. your time, our 10 a.m. So we'll just wait for the last couple of attendees who might be coming in.
Okay.
But why don't you tell us a bit about yourself, Cory?
Yeah, I'm Cory Gleasman. I'm an associate professor of computer science education at Tennessee Tech University. It's an engineering university outside Nashville, Tennessee. But what really our program and department focuses on is curriculum and instruction, but I focus on instructional design and computer science specifically. So kind of the intersection of all of those fields, I think, as technology changes, environments become more customizable. And why I kind of crossed paths with Kai's Clan in this tool I was doing a lot of game design in VR environments. I was using Unity to do some of that development, but I was looking for something where I could connect with K-12 teachers, integrate different mediums like VR and AR, and also promote computing education. And I came across this product, and it's been very beneficial in my program. And we're even doing some research with it now, which I think I'll mention in a little bit, but it's been super practical. So I appreciate you letting me share my experiences.
Now, we're super grateful to have you here. As Renelle says, we're very excited about having you here as a co-host, and this, we're very excited to bring you on board, as well as being our Mars and space race Mars judge. We're very appreciative of that.
I promise I will. I'm not a very harsh grader, and I might not be the most harsh judge, but I love looking at creative and innovative designs. So that's what I'm really looking forward to seeing all the participants and the students create is something very innovative and different and collaborative in nature.
Oh, you have such a nice way of summing things up. I guess that's why you're a lecturer.
Years of experience.
We'll just wait 2 more minutes. So maybe what got you started into education? I always like asking this because everyone has such a different sort of response.
I was a swim instructor, and I was a lifeguard. That was my high school job. And then during college, I started to teach swim lessons, and which is very different than my later career of, I guess, being a math teacher. But I enjoyed the act of teaching and learning and seeing, especially young children. I strangely worked with adults. I did like a tadpole. That was my favorite class to teach, where adults worked with their children. So parents worked with their kids, and the dynamic between the parents teaching and the children learning. I saw that like teaching was it was a skill. Some parents were really good at it, and some instructors were really good at it. Like I had some faults here and there, but I learned about myself as like an instructor. And then I realized that teaching is actually a professional skill that is valued, and the way that you can kind of cultivate that skill and curate it over time and perfect it was something I wanted to do forever. So then I started to research teaching, and I always loved technology. So then I made my way out of the pool and started working with robots. That's how I ended up here.
Oh wow! I just love how it's such an interesting story because it goes from swimming to robots. It's quite like it's quite a like fun little journey. I think that's
It is. But I think teaching and learning is at the foundation of a lot of different disciplines, and that's what I found is no matter if it's exercise science, mathematics, computer science, social studies, ELA, a lot of the same common principles are there. Um,
oh, okay. Well, I guess we're just reached 10:05, so I guess we'll start off the presentation then. So, and webinar, welcome to Mars in a Moment. Oh, I really like that name. Where we're going to go through, uh, firstly, I'll go to the next slide. We'll go through what we're going to achieve. So the space race requirements, what is required to enter the space race and what sort of level you have to be at. I'll talk through it all just in the next slide. And then after that, we have the example space race mission that Cory will go through. So he's talked through his whole process from beginning to end, and I'll demo part of it here, right in our demo room here. And then afterwards, we're going to have some tips to help for helping students create that mission or presenting that mission for the competition. And then afterwards, we'll talk about why Kai's Clan, and Cory can go into a study with some of these standards that this demo presentation has. And then lastly, a quick Q&A. Unfortunately, Faith could not make it, but we've still got lucky Dr. Gleasman here. Or sorry, you would prefer to be called Cory, right?
Cory is fine. Yes, that's fine.
Yeah, so we'll have a question and answers with Cory himself. I've got a few questions, so I can't wait to hear yours. Let's start. So for the space race competition, we have four main roles. We have home base, agriculture, construction, and mining. Think of it kind of like almost like a role that your students can take. So you could be, your students could take the construction role. So like what sorts of construction would be required on Mars, or the home base role of like what would you have to do to keep the home base afloat, or keep going. Think of like Martian the movie. That's what I see of. So once you've selected your role and the type of mission you want, the number of sensors that you need to enter the competition with is determined by the grade level. So if you're grade 4 to 6, you would only need one sensor part of the mission. If you're grade 6 to 8, it's 2 sensors, and grades 8 to 10, it's 3 sensors. So as we know, I'll take up Kai Clan is a little guy. He can also be equipped with sensors like so. So the mission requires you to equip at least one sensor if you're 4 to 6. So the competition is aimed at around ages 7 to 15. So if you are 15 for that year, that is considered for, you just can't be 16 and above, essentially. We think you'll be probably too clever for the competition. And then lastly, submissions end on the 25th of December. So registration's open now and till the end of this year, pretty much. You can get in the last minute as well if you needs be, but that's all of the sort of basis of the requirements. If there's any questions in regards to the competition, just put it in chat. I'm happy to answer, and then I'll just hand it over to Cory. So off you go.
Yeah, so to give you some insight into the process that we've gone through making some of these activities, this has been about a year process. And we've been working with the Kai's Clan larger maps to just give you some context while we designed these activities. But the first activity we designed, I like to categorize this, and I did not design these with necessarily the competition in mind at first. But then when I saw some of the criteria come out, we started to think about how we could make our designs more collaborative. But this was our first design. It was one where we had some fuel tanks, which kind of looked like rockets here, but it was what we were 3D printing at the time. They were scattered throughout the map, and a robot would travel around the map. This was more of an individual activity. They would travel throughout the map, collect different size fuel tanks, and they would bring them back to the research center, which was kind of near all of the glacier area or the ice core area. And the idea was we wanted to send an ice core back to Earth to do some studies. We decided this theme because we did some relevant research about some ice cores that were just initially found on Mars, and we wanted to build an authentic activity. So that was where the idea started. We kind of did an inquiry-based learning model, which I think is something that Kai's Clan does really well. It allows you to have some practical applications, especially with their authentic maps that are even that the smart city is one that we're looking at next to try to leverage. But you can see this was our first iteration. I would say this used one sensor because the ice core was melting based on the temperature of the room. So as they gathered these fuel tanks, they had to do it in a timely manner. There was a couple, you can read the details there on the right. There was an opportunity to gather two fuel tanks at once if they went to a specific fuel station. But this really focused on the math standard of coordinate pairs, understanding coordinate pairs, and that was really about it. We wanted it to make it more interdisciplinary, which if we go to the next slide, we can see we redesigned a little bit. So it was a very iterative process. And in this activity, we then brought in some more scientific rationale and research that the students had to do. So we then looked up, well, what is rocket fuel made out of? We did some research there, and we decided, wait, there's different types of rocket fuel. Some of the older generation rocket fuel is based on kerosene. It was a dirtier fuel compared to the hydroxyl, which was hydrogen based. However, we decided to design, just like kind of in the real world, some of these sustainable products or environmentally friendly products. Perhaps they're more expensive or they take more time to curate. So we designed our activity in that way. So now instead of just going to get a bunch of random fuel tanks, we had them gather fuel so that it made one specific fuel type. So same idea, except this time we had a focus more on science. They're still with a focus on math with those coordinate pairs, but they also had to focus on the timing, their distance, their path. It was much more complex, and it really did take a lot of time for the novice learner to go through. And then we were working with pre-service teachers and some high school students when we were doing this, and it was challenging. So I put it in the 8th grade level. I'll tell you about how I think 3 sensors could be added to all of these on a future slide. But we also had some guiding planning questions here, which turned out to take a lot more time for students, but it was a good scaffold. But we were also trying to be cognizant of time. And so I'll show you what our next iteration, which is our 3rd iteration, looks like. And we think it's a good balance. It's the best iteration we've had. And I think it's the most efficient, and it fits into that middle band grade. And if you jump to the next slide, I can talk about it. And I think we're going to demo this next version.
Yep, that's correct.
So this is our exemplar mission. This is what we've landed on. And to be honest, if you ask me in the Q&A, we're actually on a 4th iteration. That's not completely done, but I can tell you a little bit about it. But we're doing some design-based research around how we're designing these activities and utilizing all of the mediums that Kai's Clan offers. But this was our goal. So this was our theme of our lesson. Scientists at NASA need to help bring an ice core home, but they don't have enough fuel. Your job is to get enough fuel tanks to return home with the ice before it melts. This was the same theme for all of the previous lessons, but you can see how each iteration has changed a little bit. And our final exemplar activity here, challenge, something that maybe you could leverage and make. We ended up going through these processes. We condensed the fuel guide, and we made the options a little bit more simple. We provided one coordinate for each fuel station instead of having a lot of different fuel tanks all around the map. And I'll tell you why that was important when I show you the actual activity guide in a second here. But we removed planning questions. They took a little bit too long, so we just left some problem-solving considerations because we were more interested in how students were solving ill-structured problems. And I think that is one of the benefits of utilizing Kai's education products in general, even the Kai bot, I think it allows you to attack ill-structured problems, which students are going to see kind of in the real world, and it's not just a rote process. So there's not one solution pathway that can be taken to solve this challenge, and that is a strength of utilizing KAIs, but also something that we want to promote when we're promoting really thinking in our students. We scaffolded the coding blocks, which was important because not every student was necessarily proficient in Kai's Blockly language. And then we worked in teams. We utilized a process-oriented guided inquiry learning method, which is POGIL. And we gave each group, we gave them roles. So we had 3 members on each team to complete this challenge. And I mentioned in that first iteration, it was really an individual challenge. Second iteration, we added teams. And then the third iteration, we really added roles so that each student had a role, because we found that there was some problems. When I show you the roles that were given to students, you'll kind of understand. And the main goal was that it was interdisciplinary. We didn't want it just to focus on computing. We didn't want it just to focus on science or math, but we were trying to look at the intersection of all 3 of those. And honestly, a great addition that we don't have in this lesson, but I think we could, is storytelling. It's always these challenges, I think they take some type of sequence, so that ELA and social studies timelines and kind of storytelling process is always a part of it. But those sensors on the bottom, I think my OR got cut off, but I said that we could integrate 3 sensors. Let me show you the actual activity, and then I'll talk about how we can integrate these sensors. But in the back of your mind, remember the temperature sensor, a button, a buzzer, or it should say LED light. It must have got kicked to the bottom, or an LED light that we can look at. So hop to the next, and then I can talk a little bit about the team roles. So when we look at these team roles in that third exemplar mission, we gave these titles for students to choose. We could either be the logistics technician, which was really the math person, we'll say, is in this category. They were devising paths, thinking about time constraints, distance between the coordinate pairs. They were also managing the fuel types. So they were really the math and science person here. They were looking at the fuel types in the later activity. And then they were the main mediator. So we also thought about how students work in groups. And oftentimes there's one leader and then other students fall into place. And so we tried to also leverage like the dynamics of a group when we made these roles, which is part of that research method that I spoke about earlier, that process-oriented guided inquiry. We then chose a remote operator, which was really the programmer in a sense. We are not limited on devices, but we knew that sometimes school districts are. So not every student may have a one-to-one device. So having one device per group was important to us, just so this activity is also accessible to other teachers and students. And they really did the input of code, but had to work across the board with all of them to devise a plan. And then last but not least, I think it's actually one of the most important, is the astronaut. This could be one of those students that maybe doesn't feel comfortable coding, possibly isn't the STEM-focused student and is super excited, but we need to utilize everything that Kai's clan offers. And I often found that sometimes when I was using the mat, I would just focus on the 2D version, which is great. I would just focus on the physical version, or I would focus on the 2D virtual viewer just on my computer screen. But we wanted a way to leverage the VR and AR capabilities, but scaffold it so that it had to be a part of it. And that's what we did with the astronauts. So they had to join the area, join the platform in AR or VR or in mixed reality once pass-through came about. And I know Bruce and Ronell worked tirelessly with me to make sure that it works seamlessly. And it does, it works great, so that a student can go into the environment, assess the terrain, and work with the logistics technician and the remote operator and be a crucial team member while they're kind of going through these roles. So everyone here has a role, but they're all working together to solve this activity. And the roles align with the student's strengths and needs. And that's what we're focused on. And I think this is a great way to really design an activity moving forward too. And then the next slide, you can actually see our activity really mapped out some of those changes that we made. You can see we have planning considerations. We didn't have those questions. We also had some coding blocks that were limited, which was important to us. It helped scaffold that programming process. Now, we didn't limit them to just one pathway when we limited these blocks. As the educator or designer of the activity, we knew that there were multiple ways to solve this. And you can also see that there are different control structures utilized here. We have loops, we have some conditionals, we have just sequencing and some wait times and open and close grippers. And they weren't limited to just use these blocks, but we knew that these were crucial. So we went over these with our students when we introduced the activity. But you can see that we no longer just had the fuel tanks scattered around the map. We actually had them go to a specific fuel station. And then they still had to pick a specific fuel type, but they knew above that they needed 2 kerosenes and 3 hydrogen. And when we look at the actual demo, you'll notice the hydrogen fuel tanks are closer. You needed 3 to make hydrolocks under that fuel guide. However, they had to go around the terrain, which really engaged that astronaut to tell us, like, what is the terrain? What would be the best path we could choose? To reach the kerosene, you only needed 2, and it was a little bit more of a direct route because it was in the bottom left. And the astronaut also worked with the logistic technician and the remote operator to load the fuel tanks on the map, because we did often find one of the problems we had was sometimes our fuel tanks would get caught or not travel correctly, which could happen in the real world. But what we did some research on is often they'll send an astronaut from the space station to help dislodge that rover, or they will send another rover out to help. So we kind of thought about some real world applications, and we landed on having the astronaut take the person in the astronaut role take that responsibility, which also gave them another crucial responsibility in this task. We also left planning notes, which we were hoping would be pseudocode. They could kind of write out some pseudocode and complete the challenge. If we do the demo, I'm going to talk a little bit about the sensors and how we could use them. And Olivia was kind enough to kind of lead this demo and get it up and running.
Yep.
And so if we can start, I'll talk a little bit about the sensors and how we use them, because I know that's a major part of the criteria. But hopefully you enjoyed our design process and how we've gone through this. I think you'll do something similar when you make your activities. You'll continue to iterate.
Yeah, I love that notion of continuously iterating, because it's kind of what you go through in life as well. I think you continuously iterate yourself in a way. That might be too nerdy of a way to view things, though.
No, it's definitely true.
So as a FY for people who may have joined in or equivalent, we have the lesson plan that Cory has been working with, the rover roundup as shared in the PDF, as well as the slides and equivalents. If you want anything else, do please shout out or equivalent. Will did ask us a question on, will students be able to combine 2 of the different missions for their submission? I believe so. You can do that, but ideally, I think it's better to focus on the one role, because then you can really hone in on that sort of storytelling aspect as well. So you can really think about that one. But it's a good question, so thank you for that. And so I'm just going to focus on this and share my screen. And then, oh, that was a bit of inception there. So here is an example demo of Cory's rover roundup, in that we've already set it up here as an example. But so part of the rover roundup is that we're on space. So you can have your students create their own versions of what they think their rover would look like and field stations. So here I'll just grab it now. If you can see, just let me triple check that yes, so you can still see that.
Yeah, that's perfect. Yeah, we can see both.
Yeah, nice. Perfect. Thank you. So if you can see here on the top right, you'll see the field station. I've actually made that out of Lego. So if I just go front, I've made this out of Lego, and then in Tinkercad, you can bring it in to the virtual reality. You'll see it when it gets loaded in, but as an example, this is what it would look like. And to bring it in, you just go to Tinkercad, and we have instructions right here on how to do that as such. And then the next, oh yes?
Can I pause you there, Olivia? So we also found, and I mentioned this on one of the tips, but that CAD modeling is why I was also initially attracted to the Kai's Clan product, and the idea that we could have students also do this inquiry-based learning and then maybe go research what a space station model looks like or what a fuel tank would look like on space, and then go and actually CAD model it themselves. I was trying to find something that allowed my students, who were not all, they were really ed tech or instructional designers or interested in educational technology, but they weren't all computing experts, I guess, or they didn't want to be computer scientists. And this allowed them to take a different role and really work on the engineering design process, and then focus on CAD modeling and 3D printing. And it's I think one of the best parts and elements of this this mixed reality, bringing the real world into the virtual world, and then using the sensors to affect those actual CAD models. It's something that we've used, and that's what we did with the ice cube in a sense, or the ice core.
Yeah, I agree. I've personified my iceberg. I gave him little eyes.
Yeah.
As you can see here, you can upload your versions of what you think your Mars would look like. Almost, I think that the creativity in that is wonderful. Renel's just asked, "Do you have the mat there?" Yes. So if I go change it to the top-down view, this is what the Mars mat looks like. So this is what would be necessary for the competition as an example. And you can see here, we've laid out the control station and the fuel station right here. You'll see it also virtually when we go into the virtual viewer encoding. Unfortunately, Robot 3 has just died on me in terms of battery. I'm a little gutted on that, but Robot 3 here, as you can see, he's actually being connected to a glass here. And so the sensors I picked for this, for amending Cory's lesson, is that I've did the moisture sensor and the button sensor, because fuel is one of the most crucial aspects of the being on space, right? So I just got received a battery. If that the reason why I was a bit stumbly there. I'll go replace.
Yeah, if you want to replace that, I can take over kind of about the sensors. And now that we see the layout here, we can also, to explain my use of sensors, is Olivia's using the moisture sensor. I use the temperature sensor and some operators in a conditional statement, an if-then statement. So if the temperature was greater than or equal to the temperature in the room, then the ice cube started melting. In our first iteration, we actually had a hair dryer that we would use. And we would, when we got in certain parts of the map, we decided it was hotter or cooler, and it started melting the ice cube either faster or slower. But eventually we just had a incremental kind of descale of the figure. And so we just had it based on the temperature in the room. The virtual ice cube, which was also a physical CAD model that we printed, was getting smaller just because of the room temperature. So it ended up melting in 5 minutes, which was kind of like our hourglass of sand. So we kind of knew that they had 5 minutes to go do this activity, and then they had to plan out a path. We didn't tell them that it was 5 minutes initially. We just had them watching the ice cube, which was kind of an engaging way to start planning. However, because of time constraints, we were doing this activity in about an hour and 15 minutes. We needed to give them some of those, I guess, instrumental calculations and time constraints that they were under. So in that last iteration in this exemplar lesson, we gave them that it was 5 minutes when the ice cube was melting. But that just goes to show that I think it's very innovative, this product that shows that we can affect the virtual world based off the physical world, and that was the temperature in the room, and melt an ice cube. I loved it. I think it's the best thing that allows us to connect our VR technologies with our 3D printers and our computing education. And that's why I've loved these products and these activities, because it's very interdisciplinary, not just with math and science, which we can get into. But the idea in Olivia is using a button to send the robot out. I was also thinking we just use the run button, but my other idea was, say there was a storm on Mars and we needed an LED light. We could have the robot, depending on which color fuel tank it was going to, if it was going to be hydrogen or it was going to be the kerosene, that it would change that color and go receive that fuel tank at that fuel station, so that the astronaut knew what it was coming to receive. I thought that was one way we could include an LED light. We included the temperature sensor. You saw the moisture sensor. I was also thinking a buzzer. So when it's coming back to the research station up in kind of that Arctic corner, you could have a buzzer go off so that the researchers knew that the rover was returning back and it was time to go unpack the fuel tank and get ready to load it to send it back to Mars. So things like that, you can come up with different constraints, and the sensors are kind of ever changing. And I think there's a lot of ideas that you can derive from just different lights that may fit your story, which I think I mentioned earlier. I think this whole idea of creating a story within your challenge is a tip I would provide.
Ellen's just asked us a really good question. I was going to showcase how you hook up a sensor, but Ellen's asked, how familiar were your students with working with KaiClan prior to doing this activity? That's a very good question. I love that. Thank you, Ellen.
Ellen, they have never worked with it before. So we took them fresh out of a classroom. I mean, they've maybe walked past it, but this was their first time going through this activity, which made our scaffolding process super important. So when you look at these, maybe why you see some of our design changes, and we did it with a purpose of working with the, let's say, lay student who has no idea really even about block-based programming. It ended up every one person in the group had some experience with block-based programming in the past, but it was beneficial. We did teach, these students did know about computational thinking though, which helped. I won't get into the weeds of that. We're researching that. But they knew a little bit about like abstraction and pattern recognition and algorithmic thinking and decomposition, which all built into kind of the mindset of how to problem solve through these activities, which is helpful.
That was a very comprehensive answer. Thank you, Cory. So I'm just going to feel free to ask questions whenever as well. Oh, Ellen says thank you. That's very kind. Just ask whenever. We have time at the end as well if you want. But yes, that's right, Ronell. It makes the collaboration process very powerful. So I'm just going to show a quick demo of how to equip a sensor while I'm at this. So I've juiced up number 3, Chi-Rover 3. And so here you'll see there's a white tip and there's a green tip. So in your sensor box, there is an array of different types, and it will show you the different colors. So I'll just grab it. So here in your sensor box, you'll see they're green or yellow. So if they're green, like the one I have here, which is in this case the pedometer one, so it's this one here, it's green. So I take the green looking cable. There we are. So then how do we equip it? It's very simple. It's not as complicated as Arduino, thankfully. So we push the green sensor in like so. I'm just going to make sure that you can see it. Yep. And then we have the white side, and that connects to the sensor. So in this case, we have our lovely moisture sensor or pedometer. What I also like asking students when I show the sensors and show the array is like, what do you think this thing does? And I love the answers they provide, because sometimes it's something you'll never think of before. So we put that down here. So I'm just going to go top down now. and I put them in the little ice glass. So this is me simulating an iceberg in reality. As you can tell, it's very hot here in Auckland, so my iceberg's already melted. All right, so now that number 3 has juice, yes, excellent. He has detected it. So if I click on him here, you'll see that the moisture sensor is detecting it. And if we go back, oops, wrong one. If you export it and go back in history of when I equipped this guy, you'll see that the moisture was a lot lower before the iceberg is melted, and as it increases, it will go up as the iceberg melts. I've also got simulation iceberg melting with a cup of water here. What I really love about this is that you can export the yes, sorry, thank you. I realized now I'm not sharing my screen.
I was
Apologies
going
on
to say,
that.
Olivia was talking about gathering data, and I knew what she was talking about. In that bottom right, um, it is she's
Yeah.
gathering data with that moisture sensor. I saw Ronell was talking about how did we gather data. We gather data more on the time and distance that it took the robot to travel, and looking at those. We also looked at the temperature, but the temperature stayed pretty consistent and continued well, when we used a hair dryer, it would change. Like if it went under a specific or over a specific Celsius degree, it started melting. But I love the way that you can export that data and make some decisions for your next go at problem solving. That was super helpful for our students that were completing this activity.
Yeah, I agree. It also trains a bit about cleaning data and data cleanliness, which I really love as a ex-data analyst. Right, so as we'll go through, so I showed you the load data. This is where we're implementing the sensors here, and what lovely Rover 3 does, detects how much moisture, as we discussed, and minuses it from 100. So what does that mean for each scale of X, Y, and Z? Well, when I load in my little guy here, my iceberg with eyes, he will melt depending on the scale which he's melted by. So if it's 100 minus, say, 9, you'll only decrease scale X by that if the math checks out 91%. So he'll reduce in size slowly. And what I really like about doing that is it's bringing in both the reality and the virtual aspects. I think that's a lot of fun. And then at the bottom here is the second sensor, which is the button. So when the button is pressed as an instant, it will go pick up the fuel from southwest, which for those who have looked at the Space Race Exemplar mission, that would be kerosene. I picked kerosene fuel. Cory might go into which fuel pick is important as well, if you'd like.
Yeah, I can. If you look at the really how we designed this, and it was purposely put at these coordinate planes, was we did do some test runs and trials, but it looks as though that the Hydrolox fuel, it's closer, but to get around the terrain, it does take a little bit longer, which engaged with that astronaut's decision making as well, the person in the mixed reality or the VR headset. But then also, we only had to gather 2 of the kerosene fuel tanks, but that came with a time delay. So just like in the real world, sometimes the cheaper, quicker option often ends up in some environmental impact. And that's something that we wanted them to kind of research and understand, and have that implication. But they had to come up with their rationale and estimates that is that 10 seconds worth it? Maybe it's not worth it. And kind of manage those decisions, which was using data, making estimates, maybe making a trial run, then leveraging. We actually enforced that they gave us some type of pseudocode in their planning notes, and they had to have a plan before they ran a trial. So we kind of limited and managed how they used the map, just because we had 3 or 4 groups running at a time. So we tried to manage it that way, but it also helped with the planning process. We really wanted them to collaborate. And so that's another tip I would think about. I'm very constructivist. Like I want everyone just to play in an open playground, but sometimes having those rules in place helps the activity flow smoothly, especially when we're working with a lot of different mediums and roles and students.
Yeah, awesome. Great explanation. So I'll just start this code right now then. So we're gonna click run. So as a little information on the Blockly here as well, before I click run, these are all what we call functions. So I'm calling upon these blocks of code here. That makes it so the run block is really simple and easy for me to understand what is happening. It's just an easy way of breaking down your code as a tip for those who are struggling to learn how the basics of the Blockly and equivalent. I find separating it out and then going back in it helps out the process. So if I go run and I open the virtual viewer.
That also helps while that loads, using those functions. If you're sharing your classroom and you have some maybe novice programmers or some folks that aren't have any or have no experience with Blockly, or even when you switch over to Python, the text-based editor, it allows them to not have to focus on all of those blocks. It kind of just run in the background or run on your classroom, and then they can just focus on their command of the run and loop an event.
So as we can see the avatars are loading in, my control sensor, and the melting has begun. So it's waiting 15 seconds. So what we're going to do is I'm going to press my button here. So that's this code down here, and we can watch Rover 11 do his job. Alongside this, if you want a bigger view, you can click on the top right there, go share, and click that link. That link will take you to a view on a new tab. But because I want to show the code in action alongside the virtual viewer, I'm just going to do it in this method. So going from Rover 11, if I press here, oh, he's opened his view, and then he should go to platform C. I'm just going to press it again. There we go. Oh. Not sure what happened there. Sometimes we have errors, and that's okay. I'm just going to run it again.
It's the best when you have an error, because then that's probably a learning process for debugging.
I like that. That's a good point.
That's usually when the best things happen.
So we'll try this again. There we go. Grippers are open, and let's see if I can go between the screen. He keeps going straight to the end. This was just working a couple minutes ago.
Check code. Check your code.
Yes, I'll check my code. That's a good point. It's all set to 11, and we're navigating to South C. The gripper open status is true, then gripper open status is false, and then true, and then false again. So it's all to the correct robot and to the correct function. We did go through with this before, so I'm just going to try it one more time. If we go run.
Will's asking if you can show the code again.
Oh, sure, I can show the code. Maybe we can all debug together.
Yeah, we can debug it.
We'll go screen. So
This is a true interactive webinar, Olivia. This is what you do when you normally are doing this type of work.
Yeah, so what's running at the moment is it's loaded all the avatars in. So we've got the iceberg, we've got the control station. A robot 11 has disappeared. He is on, he's got all the battery. So maybe what we'll do is we'll try and push him in closer. Maybe he'll be seen then. Ah, there we go. He just couldn't be detected. So if we press again and try again, so he's opened his clothes. There we go. And off he goes to the platform C or southwest. So here the reason why we've used the navigate to platform C is so that he takes the right route. So as he goes on his journey, as we see here, he's also moving in the physical reality as well. So if I show you top down, you can see he's actually moving here. And we've got our control station and little fuel pod right here. Oh, just missed it. I'm just going to help him out there and put him in there. Sometimes it can be a little funny. So as you can see, he's actually carrying the blue kerosene fuel with him. And if I go back to the screen, he's also carrying it there with him. He's put it onto his little robot. And as he moves back, the iceberg is still healthy.
Although it is slowly getting smaller.
Yep. And then he drops it off. Ta-da!
And you can notice, so the idea will be to navigate, understand the time, go out, choose, and you can see how that's getting smaller and smaller. However, what just happened with the actual detection is we did have some trouble with some of the reflection and lighting in our classroom, and there's some settings that you can actually look at, and I'm sure you have it all set up, but we had there's some settings that I know the development team put in that allows you to help with glare depending on your lighting, which has been super helpful to us. And then also that idea of it maybe missing that pickup location just because we're using the AI navigation blocks it did happen, or maybe our fuel tank fell over. And that's why we had that astronaut role there as well. And it's been a integral part to like actually collaborate with everyone, but it also helps the activity run smoothly as well. So I think that's why we have that type of role in our group. It's been great.
Yeah, I agree. I think it really actually shows why the astronaut role is so helpful. Because when he didn't pick up the fuel, the astronaut role would be like, hang on, we didn't pick it up. So then they would have to stop the code. I love that. Thanks for calling that out. Apologies on the whole delay. I realized that Levin was just out of the perimeter. So thank you for your patience, everyone. And we got to decode together. I do appreciate it. So I will go on to the next aspect of this, which is the tips for mission creation. So maybe I'll let Cory speak on that, and I'll chime in where I think any additional tips or tricks can happen.
What is our time constraints, Olivia? When are we wrapping up? Is it at?
Well, at an hour. So this is a 1 hour webinar.
I'll cruise through these, but please return to these. I think some of these slides will be accessible to you, but these are tips that we've had when we are kind of developing and what we've learned from our development and our design. But that authentic idea, we did some research, found some authentic, real actual news clippings and went online that they were finding ice cores on Mars, and how could we develop an activity? We defined our purpose. We did some research and planning. This is kind of that inquiry-based learning model. And then we developed those roles, which I shared with you, that promoted interdisciplinary collaboration, not just collaboration in terms of, hey, sitting in a group and talking, but everyone has a role and they're focused on science, math, the technology pieces, kind of the engineering design process, and the programming. All of them had a specific role, and we have standards that we'll go through quickly and talk about that align with this. And we designed this activity with the standards in mind. It aligns with a lot of standards, but each of those roles kind of hit a specific one. The multiple pathways I talked about, that's very important. I think designing a challenge with one specific rope, process, or pathway is not true higher level thinking or higher order thinking. If you'd like to think about Bloom's taxonomy, I think it having multiple solution pathways and then having groups or teams or even individuals reflect back on their process, but also be a reflective practitioner for the other teams and understand their process. That's where the deep conceptual learning happens. So when you design an activity, ensure that there's multiple ways to solve it. Scaffolding the block usage has been really important, especially if we're working with students that have not had experience with Kai's Clan or with the Blockly programming language. In the same notion, I talked about pseudocode, but code tracing, like going over your code line by line and promoting that in some way, even when you reflect or debug, is super important. And including that in your activity, I think is great. And then leveraging the different mediums. We had that astronaut that was forced to be in VR and look at the terrain, understand, and be in an authentic environment. I like to talk about immersion. That's why I love this. They're immersed in a different medium, but they're problem solving through the same ill-structured problem as someone looking at the physical map. That's a different cognitive processes that a student's going through, and I think it's valuable to collaborate around that. The CAD inclusion and using the Kai Blockly has been all pieces that you want to leverage, especially the virtual viewer. I think that's powerful, especially if you have an iPad handy. It's really great to be able to walk around, use the AR aspect, the augmented reality aspect, but also just jump on your when you're problem solving, instead of having to run to the map, you can quickly check that virtual viewer and pull it up, and it contextualizes your problem for you.
Yeah, thank you. It's very good to those tips. I find you've almost went through all of them. That was really well concise as well. Just as a reminder as well, Cory is our judge for the space race. I did say that at the beginning, but just as for those who may have come in later, he is the judge, and the winner will get 1,000 USD. So work with your students to make those missions. My favorite tip for this creation is, define the purpose first. I find that's always very helpful when working on a problem. I believe Cory did touch on it earlier, but simply going down like what we wanting to do. So if it's mining, right, and we want to collect mining resources from all the different areas, okay, that's our purpose, right? And so what are the different areas? And it kind of highlights the steps that you need to go from there. So over to Cory on why Kai's Clan works for divergent thinking. This is about his study as well, which is really fascinating.
Yeah, I'll leave this. This can get into the academic realm and research. If you're interested in this, I'll let you reach out to me after, but I'm really interested in productive struggle and looking at computational thinking and understanding how students process different control structures. So what I like about Kai's Clan is this idea that we're using different mediums to debug and problem solve, but we're also thinking about really collaboration. And not everyone is going to be a programmer in their lives, but a lot of the next generation jobs, I think, are more complex. And I think what Kai's Clan does is it allows you to create these types of activities and challenges, and it's leveraging everybody's skills and strengths, and it's using a lot of different mediums that are cutting edge, and they seamlessly brought them all together, which is why I'm here and why I've enjoyed and implemented this technology with my teachers. Like, I'm teaching teachers how to use this technology, so it's going to be in future classrooms in the future. So I think it's important. And so I won't go into all of these bullet points. Reach out to me, and you can talk with Faith, is doing a research project. She's one of my grad students, and I have another graduate student, Mary Grace, is also running a research, and they're looking at some different avenues here.
Yeah, and if you are wanting to talk further with Faith or about Kai's Clan in particular, or have any questions at all, you're more than welcome to join our Facebook group. They're all a part of the group as well, so you can message, and I'm sure they will see the message when they log in or equivalent. So I've just put it in the chat here. So if you want, for those who are attending, if you want, you're more than welcome to join our teachers community. So as I'll go to the next slide, all of these lesson plans are, or Cory's lesson plan about the rover is relating to particular standards. So over to Cory on what type of standards these are.
Yeah, I know we have mostly, I think all teachers here that are looking into Kai's Clan or use it. And I think you can see the variety of applications it has in alignment with standards. I've placed a lot here, and these are all those 6 through 8 middle school, but you can kind of scroll through here and look at, here's our Tennessee computer science standards. I like that one about really designing, if you look at like identifying algorithms that make sequencing selection or iteration work. And so we specifically use that block limits, like limiting the block code, so that we were focusing and seeing, are you going to choose iteration and use pattern recognition or loops? Are you going to leverage conditionals and really think about selection control? Or are you just going to use maybe algorithmic thinking and just sequence blocks together? That's what some of our research is, but that's also important to think about those different solution pathways and how your students or how the participants are going to solve the problem. And that's kind of where we're designing some of these through. But all of these apply. If you jump into the next standards, you can see that we have some math standards and some on the bottom there, which is the XY coordinates. We have solving real world problems with plotting points and looking at maybe like a perimeter that they had to travel or different distances. And then if you hop over to the next science standards, you can see that like calculating the average speed, using distance and time, asking questions, and solving problems based on like a model or observations or some of the data that we kind of gathered and used. And then the size and the scale and melting the ice, all of these things can be used for science. And not even to talk about that we're working with planets and on another environment that opens itself up just to some science standards as well.
Oh, thank you, Cory. So last 5 minutes is any questions for Cory? If not, I have some questions here I've gotten from both around the office and other teachers that I were talking to. But please, if you have any other questions, now is the best time to ask, especially someone of such a high caliber and understanding about curriculum and lesson plans. So I'll just ask one of my questions here. So with curriculum design in particular, because I believe you specialize in there as well, correct? Yes. So how do you balance the sort of theory with the practical application, as you saw right here? How do you balance the two between like the academia world and all of the pedology and equivalent to the actual practical application to a practitioner almost?
Yeah. You know, it kind of goes back to that first question you had, which I'm surprised. Well, we can almost bookend our conversation with, it didn't matter if I was teaching a swim lesson or teaching robotics in Kai's Clan, this idea of like experiential learning, like the theory behind that and different stages of Cobb's experiential learning, or Lev Vygotsky, who's an educational psychologist and talked about ZPD, which is like zone of proximal development, like keeping students scaffolding the learning environment enough so that, I like to say, productively struggling, but they're still challenging themselves. So you're giving them enough to continue to learn and navigate concepts. And maybe they're not going down the right path, but you can redirect them. That's the true art of teaching. And regardless of what technology I'm using, or it could be no technology at all, it could be like a technique for swimming. The idea is kind of all the same. So the theory, I think, is truly foundational. And there's a lot of seminal work out there that I think still applies regardless of what innovative technology we use. And so I rely on that. And I just love integrating new engaging tools. And I think that's what Kai's Clan is. I kind of talked about all the mediums that I love to integrate into a collaborative learning environment. And that's why I use this product in my program.
Oh, thank you. Thank you for answering that question. I know I say that a lot, but I'm very grateful that you're willing to come on board and
No, of course.
my question.
That's none of the that's what I do. And Olivia, she's super kind. But I think I always go back to this idea is like my first iteration of this wasn't perfect. So when you design your first challenge, it may not go exactly how you thought. And there's always like faults and weak points. And I do something called like design-based research, and it's all about learning not the outcome specifically, but learning the design decisions that you made. Like that's what's important and probably leads to learning. Same for your students. Like if they're designing this activity, it's not necessarily like how great maybe that final activity it is. How did the progress change? It's almost like progress monitoring for a teacher that they do with students. How did you change from that first iteration to the last one? That's what I would almost be looking at when I'm looking at these activities. It's like, hey, you ended up here, but I can kind of see your process and maybe why you ended up with this activity you did, because it never works the first time.
Yeah, I think that's the joy of coding in a way.
Yeah.
Or the struggle, whatever you prefer. So Kay has just asked a quick question on, do you also cover Python with Chi-Plan, or is it just Blockly? Yes, we do cover Python as well. So I'm just going to share my screen again and enlarge it. So as you can see, the little Python icon here, if we click on it, you'll get this cool background of Python, and it should show what Cory's code is, for example, my code in Python. So you can start seeing the syntax of what you necessary to write the Blockly into an actual language used by thousands, if not millions, of coders in the world. And if your students are becoming too reliant on the Blockly and you want to help them move away from that sort of area, if you click the hamburger here, you can actually block the Blockly code here, which I think is really powerful because it starts enabling that translation. So that's it for the end. I want to really thank Cory for coming on board, and I really appreciate him coming along, and thank you as well. And there's the link to the Facebook community if you like. So thank you.
Thank you all.